Hello students, how are you? I am Dr. S.K. Das from Regional Institute of Education, Bhubaneswar. Once again, I am standing before you for an interaction about an interesting chapter, motion of your class, which is there in your NCERT textbook. Well, before we start our discussion, let us see what we have learnt in the last class. First of all, we have studied rest and motion. Then we have studied rest and motion are related terms. Then we have studied types of motion such as linear motion, circular motion, rotational motion and vibrational motion. Then we have studied distance and displacement in linear motion. Well, then we will discuss what we will learn today. Today we will learn about speed, then we will learn about velocity, then we will learn about acceleration of an object in linear motion. In the last class we have already discussed about linear motion. So all these parameters, speed, velocity, acceleration of the object, we will discuss in linear motion only. What we should understand first? First of all, we need to understand about uniform motion and non-uniform motion of an object which moves in a straight line path with the help of some interactive pictures. Please see this picture along with its data sheet. Of course, this is an activity. So here you see an object is falling freely under the action of gravity. You know, gravity is pulling the object is falling downward under the action of gravity. Now you see the data sheet of this activity, so which shows the variation of distance covered by that object falling freely under the action of gravity against time. Now see the data sheet. First of all, see the activity. The object is falling freely. The object whenever falling freely, so there is graduation on the body on which the body is falling freely. So here you see the distance covered by the object is in terms of centimeter and time taken that object to fall freely is in terms of second. First you see it is covered the distance of 0 to 5 centimeter in 1 second, then distance of from 5 to 10 second, 10 centimeter in 2 second, then 10 centimeter to 15 centimeter in 3rd second, then 15 to 20 centimeter in 4th second, then 20 to 25 centimeter in 5th second, then 26 to 30 centimeter in 6th second. So now from this activity, what do you observe? Once again I am showing the activity. The object is falling freely. Now see the distance. So distance is 5 centimeter interval and see the time, it is 1 centimeter interval. Then if I ask you the question, what is your observations? You will see that the object is falling freely, no doubt about that. But equal distances of 5 centimeter is covered by the object in equal time interval of 1 second. Am I right, students? You see, once again, it is 5 centimeter, see the data sheet, and in the time column it is 1 second, 1 second, 1 second. That's why whenever it falls from 0 to 5 centimeter, time taken is 1 second, then 5 centimeter, 10 second, 10 centimeter, time taken is 2 centimeter, 2 second. In this way, you see, so there is equal distances of 5 centimeter covered by the object in equal time interval of 1 second. Well, you see one more activity from this picture. A toy car moves on a horizontal straight line path which is marked with equal distances of 10 centimeter. Am I right? You see the toy car is moving from left to right. Now marking is there on the straight line path: 0 centimeter, 10 centimeter, 20 centimeter, 30 centimeter, 40 centimeter, and so on. Now on the top it is mentioned 1 second, then 2 second, then 3 second, then 4 second. That means the toy car moves from left to right. So whenever the toy car moves from left to right from 0 centimeter to 10 centimeter, time taken is 1 second. Then whenever toy car continues to move from 10 centimeter to 20 centimeter, the time taken is 2 seconds. Whenever toy car moves from 20 centimeter to 30 centimeter, the time taken is 3 seconds. Whenever it moves from 30 centimeter to 40 centimeter, the time taken is 4 seconds. Well, you see, what is your observation? So you see, toy car covers equal distance of 10 centimeter in time interval of 1 second. Am I right? Once again I am showing that picture. Distance you see 0 to 10 centimeter, distance is 10 centimeter, 10 centimeter, 20 centimeter, distance again 10 centimeter, then 20 to 30 centimeter, distance again 10 centimeter, 30 to 40 centimeter, distance again 10 centimeter. That means toy car covers equal distance of 10 centimeter in time interval of 1 second. Well, what does this example show? What is striking to your mind? Two examples I have kept before you. In the first case, an object is falling freely under the action of gravity, and the data sheet is along with that activity. So the object is falling freely under the action of gravity in such a manner that it covers equal distance of 5 centimeter in equal intervals of time of 1 second. And in the second activity, you see toy car covers equal distance of 10 centimeter in time interval of 1 second. So what would be your observation? These examples shows that the motion of the object is uniform. Then let us discuss the definition of uniform motion. Uniform motion means if the object covers equal distances in equal intervals of time, then the motion is known as uniform motion. So these two examples, whatever we have discussed just now, these are in favor of uniform motion, because in both the examples equal distances are covered by the objects in equal intervals of time. That's why both the examples are in favor of the uniform motion. Well, let us see one more interactive picture. See this picture. Once again it is a toy car. It moves in a linear motion in a horizontal straight line path, which is marked with unequal distances. It has not equal distances in centimeter scale, of course. See the marking. At first it is 0 centimeter, then 20 centimeter, then 30 centimeter, then 45 centimeter, then 55 centimeter, then 70 centimeter. That means the straight line path is marked with unequal distances in centimeter scale. Now you see the toy car moves. Whenever it moves from 0 centimeter to centimeter, time taken by the toy car is 1 second. It is mentioned on the top. Then whenever it is moving from 20 centimeter to 30 centimeter, the time taken is 2 seconds. And whenever the toy car moves from 30 centimeter to 45 centimeter, the time taken is 3 seconds. And then it will take 4 seconds whenever it moves from 45 centimeter to 55 centimeter on the linear path. Then you give your observation. Then I will ask this question: what do you observe now. So you see, in this case, the toy car covers unequal distances in 1 second time interval. Just recall the previous activity with the help of the toy car. The toy car was covering equal distances in equal intervals of time. But here the situation is different. The toy car covers unequal distances. So what is that unequal distance? Let me show you this picture once again. Unequal distance C, 0 centimeter, 20 centimeter, distance is 20 centimeter. Now 20 centimeter to 30 centimeter, distance is only 10 centimeter. Then from 30 centimeter to 45 centimeter, distance is 15 centimeter. Then 45 centimeter to 55 centimeter, again distance is 10 centimeter. Then 55 centimeter to 70 centimeter, now see the distance, it is entirely different. That means this shows that the toy car covers unequal distances in 1 second time interval. So what does such example show? What would be your answer? Can you guess some answer in favor of this question? Well, such example shows that motion of the object is non-uniform. But the previous example with the toy car shows that the motion of the object is uniform. I have already explained in my previous activity. Now let us define the term non-uniform motion. An object is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. Right? So in the previous activity you have seen equal distances are covered by the object in equal intervals of time. But here in non-uniform motion, the object covers unequal distances in equal intervals of time. So this is the definition of non-uniform motion. Well, let us see this table which shows the data sheet of the motion of two objects A and B in terms of distance travelled against time taken. Am I right? So let me repeat the situation. There are two objects A and B. Both the objects are in motion. Now we are taking the data sheet. In the data sheet, the distance travelled by both the objects against time is recorded in the tabular form. See, I have given three columns. First column is the time column. The second column is the distance travelled by object A. The third column is distance travelled by object B. So in the first column, time I have started at 9:30 am. Then I have ended at time 11 am. Now at the first instant, time taken at 9:30 am and distance travelled by object A is 10 meter and distance travelled by object B is 12 meter. Then at time 9:45 am, distance travelled by object A is 20 meter, distance travelled by object B is 19 meter. Then at time 10 am, distance travelled by object A is 30 meter and distance travelled by object B is 23 meter. Then at time 10:15 am, distance travelled by object A is 40 meter and distance travelled by object B is 35 meter. Then at time 10:30 am, distance travelled by the object A is 50 meter and distance travelled by the object B is 37 meter. At time 10:45 am, the distance travelled by object A is 60 meter and distance travelled by object B is 41 meter. Lastly, at time 11 am, the distance travelled by the object A is 70 meter and distance travelled by object B is 44 meter. Well, students, so you have carefully observed the table. Let us move towards your findings. What would be your findings? You see, the object A is in uniform motion as it covers equal distances of 10 meter, 10 centimeter, 10 meter in equal time interval of 15 minutes. So here in this case, object A is in uniform motion. I have already told you the definition of uniform motion, in which the distance covered by the object should be equal in equal intervals of time. Is it not happening in this situation? Yes, of course. In this situation, the object A is covering equal distances of 10 meter in equal time intervals of 15 minutes. Therefore, I mentioned that the object A is in uniform motion and it covers equal distances of 10 meter in equal time intervals of 15 minutes. So what about the nature of motion of object B? Whether the nature of the motion of the object B is similar that of the nature of the motion of the object of A? No, not at all. Then what is that? You see, the object B is in non-uniform motion. Why? As it covers unequal distances in equal interval of 15 minutes. I have already given you the definition of non-uniform motion. In the non-uniform motion, the object moves on equal distances in equal interval of time. So here in the table, distance travelled by object B, it is well mentioned. The unequal distances are there on the table: 7 meter, then 4 meter, then 12 meter, then 2 meter, then 4 meter, then 3 meter. So these are the unequal distances travelled by object B in equal intervals of time. What is the time interval? 15 minutes. So therefore, the object B is in non-uniform motion as it covers unequal distances in equal time interval of 15 minutes. Well, students, you understood about uniform motion and non-uniform motion with the help of some activity, with the help of some interactive pictures. So now it is your turn. You please give an example of non-uniform motion from your daily life experiences. So here, what example you will cite? We all are very familiar of traveling one place to another place by using a car. Am I right, students? Okay. So whenever we travel in a car on a crowded road, you must have seen the road condition. Sometimes the traffic is very heavy, sometimes the traffic is very light. Whenever the traffic is very heavy, then of course that road is said to be a crowded road. So whenever we travel in a car on a crowded road, the motion of the car is said to be non-uniform. So can you answer me this question? Why the motion of the car in a crowded road is non-uniform? Well, you please think, because I have already shown you some activities, shown you some interactive pictures, and I have already given you the definition of uniform motion and also non-uniform motion. From that, you please understand the situation why the motion of the car on a crowded road is said to be non-uniform. Then, in this situation, that means the car is in motion in a crowded road. So that is the situation. So in this case, that is in this situation, car sometimes covers unequal distances in equal interval of time or equal distances in unequal interval of time according to the condition of the traffic on the road. So this is the hint I have given to you all for your critical thinking. Now, whenever you travel from one place to another place in a car, then you think about it and verify that the car covers unequal distances in equal intervals of time or equal distances in unequal intervals of time according to road condition of the traffic and the situation, and also you verify that the motion of the car is non-uniform. Am I right, students? Well, then let us shift our discussion about the concept that how fast and how slow an object moves. Again repeating, the concept is how fast and how slow an object moves. Please see this picture. What do you see in this picture? So here a fast bowler of our Indian cricket team is bowling. Who is that fast bowler? Okay, Bumrah is the fast bowler. Am I right? Okay. So Bumrah is the fast bowler giving his ball to the batsman. So what is the speed limit of Bumrah? Is it there in the TV screen? Of course, it is there in the TV screen. What is that? The fast bowler Bumrah is bowling with a speed of 150 kph, kilometer per hour. In the TV screen it is appearing kph. Kph means kilometer per hour. Fine. The bowling speed of Bumrah is 150 kph. Then please see one more picture. What do you see in this picture? You see the spinner of the Indian cricket team, Chahal, very important spinner of our Indian team. Chahal is bowling. But what is the speed limit of the spinner Chahal in this picture? The speed limit of the spin bowler Chahal is 90 kph. It is mentioned in the TV screen. 90 km per hour. The fast bowler speed limit 150 km per hour. The spin bowler speed limit 90 km per hour. Well, after observing these two pictures, so what would be your critical observation? You see, I have already mentioned the concept how fast, how slow an object moves. So then you will come to the same, concept how fast and how slow an object moves can be measured by its speed. Because I have given the pictures. One picture, Bumrah is bowling. Second picture, Chahal is bowling. Bumrah bowling speed is 150 km per hour. Chahal bowling speed is 90 km per hour. Then you see Bumrah is a fast bowler. Chahal is a spinner. That means slow bowler. That means how fast or how slow an object moves can be measured by its speed. Am I right, students? You must be enjoying cricket, no? Some of you might be a very good fast bowler. Some of you might be a very good spinner. But whenever you give your ball to the batsman, sometimes you give, high speed bowling. Sometimes you give low speed bowling with spinning action in the cricket ball. Well, you must have enjoyed and you must be integrating that sports life with your study. Well, thank you so much in that way. So let us move towards the definition of this speed. What is speed? It is the distance travelled by an object per unit time irrespective of the direction of motion of the object. So this is the definition of the speed. Then speed equal to distance travelled divided by time taken, because it is the distance travelled by an object per unit time. How much distance travelled by the object per unit time? That's why speed equal to distance travelled divided by time taken. It is denoted by the letter V. Symbol is V. Symbol of speed is V. It is a scalar quantity. Well, students, you must be recoiling your previous class knowledge. I have already mentioned distance was a scalar quantity, whereas displacement was a vector quantity. So in that class I have mentioned scalar quantity, that quantities which can be described only by its magnitude. On the other hand, vector quantity is that quantity which can be described completely with the help of both of its magnitude as well as the direction. Here you see speed is a scalar quantity because it could be described by its magnitude only. That is 190 km per hour, 90 km per hour, 30 km per hour, 40 km per hour, so on. So this is the magnitude of the speed. If the distance travelled by the object is s in time t say, then the speed of the object is v equal to s upon t. Distance travelled is s, time taken is t, therefore v is the speed equal to s upon t. Well, do you know the unit of speed? Please think. Well, SI unit of speed is meter per second because distance is measured in meter, time taken is measured in second. Therefore, SI unit of speed is meter per second. The CGS unit of speed is centimeter per second. What is the other unit of speed? Just now I told the Bumrah bowling speed, Chahal bowling speed, that is kph, kilometer per hour. So other unit of speed is kph or kilometer per hour. And whenever you convert 1 kilometer per hour, 1 kph in terms of meter per second, you see 1 kph equal to 5 by 18 meter per second. You please do the exercise and verify this result, whether 1 kph equal to 5 by 18 meter per second or not. Well, let us, see this device. Can you see this device? Can you recognize this device? It is there in all the automobiles in our everyday life. It is there in the car, it is there in our bike, it is there in our scooty. So, can you recognize this device? This is the device used for measurement of speed. Am I right? Well, what is the name of this device? The name of the device is speedometer. Speed is measured by using a device known as speedometer. So this is the picture of a speedometer. If the pointer of the device moves towards 60, then the speed of the vehicle is 60 km per hour. If it is moving towards 80, then speed of the vehicle is 80 km per hour. If the pointer is moving towards 70, then speed of the automobile is obviously 70 km per hour. But there is another device which can be used for measurement of distance. Do you know that? Of course, that device is fitted along with the speedometer. So the name of that device is odometer. So distance is measured by the device known as odometer. Can you see odometer in this picture? Please, you find where is the position of odometer. Speed you can determine with the help of the pointer reading of the speedometer. Odometer is there, of course, at the central part of this device. So where the distance covered by the automobile has been shown in terms of letters. Well, let us discuss this concept, that is the concept of speed, with an interactive question. Am I right? If you think some interactive question, or if you solve some interactive question, then you can understand the concept well. Now the question is like this. What is the speed of a bus which travels 40 km in first hour, 40 km in second hour, 40 km in third hour, and all total 120 km in 3 hours? This is the question. Do you understand the question, students? Well, once again you see the picture. In the picture, I have shown that the bus is moving from left side to right side. Whenever it moves from one end to other end, let's say the bus travels 40 km in the first hour, 40 km next say hour, that is second hour, 40 kilometer in the third hour. All total 120 kilometer traveled by the bus in total time of 3 hours. So therefore, the distance travelled, as I have mentioned in my discussion, that it is denoted by the symbol S, S equal to 120 kilometer, time taken T equal to 3 hours. So bus is moving in a straight line path in 3 hours. Well, if you go for its solution, we know speed equal to distance travelled by time taken, V equal to S upon T. Here you substitute the value of S, substitute the value of T, T is the time taken. 120 kilometer upon 3 hour is equal to 40 kilometer per hour. So speed of the bus is 40 kilometer per hour, 40 kph. So this 40 kph is the speed of the bus. Is it the uniform speed or non-uniform speed? So you must be agreeing with me that it must be the uniform speed of the bus. Well, students, can you answer me why the speed is said to be uniform in this case? You please see, in the first hour, the bus travels 40 kilometer. In the second hour, again 40 kilometer. In the third hour, again 40 kilometer. That means the equal distances travelled by the bus in equal intervals of time. So therefore, in this case, the bus moves with uniform speed of 40 kilometer per hour. Well, let us see one more picture. Here you see the vehicles, bus, car, bike, scooty, etc. moving on a road as per the requirement of the traffic. Sometimes the bus is moving with some higher speed, then the bus speed decreases. Sometimes the car moves with low speed, then its speed increases. Sometimes the bike speed increases, sometimes decreases, and scooty speed increases and decreases, and so on. So in this situation, what would be your observation? We know that the speed of the bus, car, scooty, bike, etc. moves on the road in different speed. That is, speed does not remain constant. Therefore, the vehicles move with variable speed on the road, with different speed on the road. So what is the indication of such variable speed? So let me give an example once again. Suppose the scooty, at first it moves with higher speed for 10 minutes, then it moves with lower speed for 10 minutes. That means at first higher speed for 10 minutes means less distance covered in 10 minutes, lower speed with 10 minutes means larger distance covered in the same 10 minutes. So therefore, this motion is non-uniform motion, because in this situation unequal distances travelled by the scooty in equal intervals of time. That's why the scooty is with variable speed. So now my question is, what is the indication of such variable speed? Well, you see, the variable speed of the object indicates non-uniform motion or non-uniform speed of the object. I have already convinced you about this, because unequal distances travelled by the vehicles in equal intervals of time, therefore the speed is variable, and I have mentioned the indication of such variable speed is definitely gives non-uniform motion or non-uniform speed of the object. Well, the rate of change of non-uniform motion or non-uniform speed of the object is described by its average speed. This is a very important thing you have to understand. You know, we all are in non-uniform motion on the road whenever we are with our bikes or maybe with the cycles. Then in that case, we need to describe the speed of our vehicles with the help of the average speed. Let us define the term average speed. Average speed is the total distance travelled by the object divided by the total time taken to cover that distance. So this is the definition of average speed. Once again, I am repeating in terms of some equation. Average speed equal to total distance travelled upon total time taken. Total distance travelled by total time taken will give rise to average speed. It is denoted by a symbol. You know, the symbol of the speed is V. So here V is also there, but in the subscript AB is mentioned. So VAB is the symbol used for average speed. Oh, well, so let us discuss the concept of average speed with the help of some interactive questions. The first question is, what is the average speed of a car which travels a distance of 100 km in time 2 hours? Once again repeating, the car is in motion and average speed of the car is being asked in this question, and the car covers a distance or travels a distance of 100 km. What is the time? Time is 2 hours. Can you solve this question? Yes. Students, now you are familiar with the questions, asking questions and solving questions. Now you must be tempted to solve such critical questions, thought-provoking questions. So here the average speed, you know, I have already mentioned in the definition of average speed, total distance covered by total time taken. Here total distance travelled is 100 km, total time taken is 2 hours. That's why average speed equal to 100 km divided by 2 hours is equal to 50 km per hour. The average speed of the car is 50 km per hour in this case. Okay. Well, students, can you tell me whether the car in this situation is in uniform motion, non-uniform motion? Well, your answer is very right. The car in this case or situation moves with non-uniform speed. Then only we are going for average speed. Otherwise, why should you go for finding the average speed? Unequal distances travelled by the car in equal intervals of time. So that's why the speed is non-uniform. So here average speed 50 km per hour as because the car is in non-uniform speed. Let us see the second question. What is the average speed of a car which moves 30 km in time 30 minutes and next 30 km in time 40 minutes? See the critical questions. First 30 km in time 30 minutes, next 30 km in time 40 minutes. That means the road must be crowded road. Am I right, students? Otherwise, why 40 minutes taken by the car in the next 30 km travel? Can you solve this question? Well, the solution of this question is very simple. In this case, the car covers equal distances in unequal intervals of time. I have already mentioned, whenever the motion is said to be non-uniform, then either unequal distances must be travelled by the object in equal intervals of time, or equal distances must be travelled by the object in unequal interval of time. Now the second case is coming here. That's why I mentioned the car covers equal distances in unequal intervals of time. Once again I am showing the questions. See the unequal intervals of time. In the first case 30 km covered in 30 minutes. In the second case 30 km covered in 40 minutes, unequal intervals of time. So this is the case. That's why the motion of the car in this case is said to be non-uniform. But the task is to find out the average speed of the car. We know the definition of the average speed. Average speed equal to total distance travelled divided by total time taken. So here total distance travelled 30 km plus 30 km divided by total time taken 30 minutes plus 40 minutes equal to 60 km divided by 70 minutes equal to 60 km divided by 70 by 60 hours. I have converted 70 minutes into hours. You know 1 hour is equal to 60 minutes, or 1 minute is equal to 1 by 60 hour, or 70 minutes is equal to 70 by 60 hours. Therefore, this is equal to 60 kilometer divided by 70 by 60 hour equal to 60 into 60 divided by 70 kilometer per hour equal to 3600 divided by 70 kilometer per hour. If you solve this, it is equal to 51.4 kilometer per hour. So the average speed of the car is 51.4 kph. What is the meaning of kph? Good, kilometer per hour. Well students, we have discussed some interactive questions on the concept of speed. Now I will give you a task to perform this activity with the help of the toy train. So please see, this is a toy train. Now the toy train is moving in the circular track having diameter 62 centimeter. Please remember, the diameter of the circular track is 62 centimeter. See, if the diameter of the circular track is 62 centimeter and the toy train is moving in the circular track, you have to determine the average speed of the toy train. What will be the average speed of the toy train if it travels in this circular track having diameter 62 centimeters and time is, say, for one complete rotation it is 2 minutes. Again I am repeating, the toy train is moving in the circular track. The diameter of the circular track is 62 centimeter and time taken to cover one circular track by this toy train is 2 minutes. Then you have to find out the average speed of the toy train in this situation. So this is the task I am giving you by performing this activity. Well students, you have understood the concept of speed, average speed very well. Am I right? You must have enjoyed the topic. Let us see what we have learned today. First, we have learnt about the uniform motion. The motion of an object is said to be uniform if it covers equal distance in equal intervals of time. Then we learnt about non-uniform motion. The motion of an object is said to be non-uniform if it covers an equal distance in equal intervals of time. Then what we have learnt? We have learnt about speed. Distance travelled by an object per unit time is the speed. Speed is measured by speedometer. Then we have learnt about the concept of average speed. So total distance travelled by an object during its non-uniform motion divided by total time taken to travel that distance. So this will give rise to the concept of average speed. So till this concept we have discussed elaborately, nicely with some interactive questions and some interactive activities. I think you must have enjoyed the topic and you must be solving more critical questions and you must be doing more activities. Am I right, students? Well, thank you so much.